This is Priyadharshini, working as an assistant professor in the Department of Artificial Intelligence and Data Science. So today we'll continue with the session Process Scheduling in Operating System. So what is process scheduling? Why the process scheduling is needed? So when we talk about process scheduling, it is the activity of the process manager that handles the removal of the running process from the CPU and then selecting another process on the basis of the scheduling algorithms. So the module of operating system that makes this decision is called the scheduler. So there are 3 queues available in the scheduling. So the scheduling queues refers to queue of processes or devices. So there are 3 queues as I told you before. One is job queue, the next one is ready queue and the device queue. So what is a job queue? When the process enters the system, then this process is put into a job queue. This queue consists of all the processes in the system. The processes that are residing in main memory and are ready and waiting to execute are kept in the queue called the ready queue. This queue is generally stored as a linked list. Another queue called the device queue, in which the operating system maintains the set of all devices. So here it consists of multiple processes are waiting for a particular input-output devices. So this is the representation of process scheduling. So the job queue, first remember, job queue will be available in the secondary memory. So job queue consists of all the processes that need to be executed. So from the job queue, the scheduler dispatches the processes which are ready to be executed, will be taken back to the ready queue, and then from the ready queue, the scheduler decides which process should be executed. So if there is no problem or if there is no error or no interrupt, then from the ready queue it will be sent to the CPU for execution, and then the process will complete its execution. Suppose there are some cases for the process scheduling. Suppose if a process requests for an IO resource or an IO request, then it will be sent to the device queue, and then it will wait till the IO IO execution is completed. In that time, it is again put it into the back into the ready queue. Otherwise, if the process is executing and if its time slice being expired, then again it will put back into the ready queue. Or in other case, if it forks a child, if it wants to create a child, then the process will wait until the child executes, and then it will be put back into the ready queue for the process to be in the waiting state. So in other cases, the process waits for an interrupt, then it waits until the interrupt has been finished, and then it will be taken back to the ready queue. So once again it will be sent to the CPU by the dispatcher, and then the process completes. So this is the queuing representation of the process scheduling. So here I'll detail what I have given previously in the diagram. I'll tell you again. So that was a common representation of process scheduling that is called as a queuing diagram. So queue is represented by the rectangular box. The circle represents the resources that serve the queues. The arrow indicates the process flow. So when you see, the queues are all represented in the rectangular box, and the processes that are being done is executed in the oval or the circles. Then the flow is denoted by the arrow diagram. So queues are of 2 types, ready queue and device queue alone will be shown anywhere, because the job queue will be available in the secondary memory. So here a newly arrived process is put in the ready queue. Process waits in a ready queue for allocating the CPU. Once the CPU is assigned to the process, then that process will execute. While executing the process, it may be in any of the following event. If the process issue an IO request, then it will be placed in an IO queue. If it creates new sub process, and it will wait for its termination If it is been forcefully removed by the CPU, then it results in an interrupt and then put back in the ready queue. So there is a two-state process model. So one is running state, other one is non-running state. So as we know, running state, when new process is created by the operating system, that process enters into the system as in the running state. If the processes that are not running are kept in the queue waiting for their turn to execute are termed as non-running states. So schedulers, so as I told you, the decision is taken by the schedulers. So there are three types of schedulers: long-term, short-term, medium-term scheduler. So long-term scheduler is also called the job scheduler. So it determines which programs are admitted to the system for processing. Short-term scheduler or the CPU scheduler selects among the processes that are ready to execute and allocate the CPU to one of them. Medium-term scheduler, so this can be best described by the swapping. Medium-term scheduler removes a process from main memory and stores it into the secondary storage. After some time, this process can be reintroduced into main memory and its execution can be continued where it is left off. So this is called a swapping. So in the medium-term scheduler, it moves a process from CPU to input-output waiting queue and from input-output queue to ready queue. So this is the two tasks that is mainly done by the medium-term schedule. Thank you.